Okay, guys, today's bell ringer just reviews what we've been talking about so far, just in reviewing proportional relationships. We did look at it yesterday in a table that was in our bell ringer and exit slip. So today we're going to look at it in a graph. So think for just a minute about how we know from looking at a graph if it's proportional or not. So if you remember, a graph is proportional if it is a straight line that passes through the origin, and it has to do both of those. It can't be just a straight line. So in this second graph over on the right-hand side, it is a straight line, but that straight line does not pass through the origin, so that one would not be proportional. However, the one on the left, it does pass through the origin down here at 0, 0, and it is a straight line, so that one would be a proportional relationship. So today we're going to start on our probability standards with statistics. So we're going to do probability of simple events today. So the first example says a circus has 18 performers, of which 3 are dancers. What is the probability that a randomly selected performer will be a dancer? Write your answer as a fraction or a whole number. And when you write it as a fraction, it has to be in simplest form, or I think IXL will count it wrong. I'm not 100% sure, but I would encourage you to put it in simplest form. So if there are 3 that are dancers out of 18 performers, you're just going to simplify that, and you can do that in your calculator. So 3 numerator, 18 denominator, and then hit your simplify button, which would simplify to 1/6. So the probability of a dancer being chosen at random would be 1/6. Okay, example 2 says a dartboard has 15 equal sections, of which 6 are red. What is the probability that a dart will land in a red section? Okay, so we're going to do, we read this down here, by the way, as probability of red. So that would be 6 were red out of 15. And we're going to simplify that. So 3 goes into 6 2 times, and 3 goes into 15 5 times, or you're welcome to use your calculator, and we would get 2/5. Okay, you pick a card at random. What is the probability of choosing a 3? So what's the probability of choosing a 3? Well, out of those cards, only one of them is 3. Out of how many cards are there? Which is 4. Now, you'll notice in this one, your answer is as a percent. Again, you can still enter 1/4 as a fraction on your calculator, and then hit your change to percent key. That is 3 buttons above the 7. It's got the arrow beside the percent. But you should automatically recognize that 1/4, it's like having a quarter of a dollar, which would be 25%. Okay, in example 4, it says there are 6 tables set up for a banquet, of which 2 have purple tablecloths. What is the probability that a randomly selected table will have a purple tablecloth? And we read this as the probability of it being purple. So 2 are purple out of 6, which would simplify to 1/3. Okay, you roll a 6-sided die. What is the probability of rolling a 5? Well, there's only one side on a die that is got the 5 on it, so 1 out of 6, and that is already simplified. A bakery has 20 desserts for sale, including 2 slices of pie. What is the probability that a randomly selected dessert will be a slice of pie? So 2 out of 20 would simplify to 1/10. Okay, Morning Muffins has a variety of muffins for sale. What is the probability that a randomly selected muffin will be a chocolate chip muffin? Okay, so in this case, we're going to have to add up all the different types of muffins. So you can use your calculator and go ahead and do that. So there's a total of 65 muffins, and we're looking for the probability of a chocolate chip. So the chocolate chip muffins was 15. And then you'll need to simplify 15 over 65. Again, you can use your calculator to do that. And you get 3 over 13. Okay, take just a minute. You roll a 6-sided die. What is the probability of it being a prime number? Remember, a prime number means a number that the only factors is 1 in itself. So we know that there's 6 sides on the die. So how many of those numbers? We know that on the die 1, 2, 3, 4, 5, and 6. Okay, 1 is not a prime number. However, 2, the only way you can get 2 is 2 times 1, so that makes it prime. 3 is only 3 times 1. Now 4, we could do 4 times 1 or 2 times 2, so that one is not prime. 5, the only way to get 5 is 1 times 5. And then 6, we could do 2 times 3 or 6 times 1, so that one's not prime. So we can see that 3 out of those 6 numbers are prime. So we need to simplify 3/6, which would simplify to a half. Or if your answer choices is in percents, then obviously a half is 50%. Okay, of the people attending a seminar, 15 have black hair and 27 do not. What is the probability that a randomly selected person will have black hair? So take just a minute and do that. Be very careful with it telling you that 15 have black hair and 27 do not. This one has an extra step in it. So you're looking for the probability of black. Okay, so how many of them had black hair? 15 did. But 15 out of how many? Well, if 15 have black and 27 do not, we have to add those two numbers together to find the total. So 15 had black hair out of 42 people. And then you will simplify your 15 over 42, which would give you 5 over 14. So be careful. Sometimes you're going to have to add those two numbers together, and sometimes you won't. Okay, go ahead and take just a minute and complete number 10. Okay, you spin the spinner once. You're looking for the probability that it lands on a number less than 8. Okay, so any number less than 8. So that's really all of them except 8. So that would be 7 out of 8 of them would be less than 8. Now notice it's giving you your answer choices as percents. So you can just do 7 divided by 8 and move your decimal, or you can enter 7/8 as a fraction and hit that change to percent key. That's the one that's got the arrow beside the percent sign, which is 87.5. Okay, our exit slip again is looking at proportional relationships. This time we're looking at the equation. So we've looked at tables yesterday in our bell ringer and exit slip. This morning we've looked at graphs. Now we're going to look at an equation. Okay, so if you'll remember a long time ago, we talked about y equals kx, and k was our constant. Okay, so which one is written in the form of this y equals kx? Well, our first one does not have an x on it, so that cannot be a proportional relationship. However, we're told here 7/5 is our constant, and we have that x just like our equation says we should. So y equals 7/5 x would be a proportional equation. All right, you're going to go ahead and get started on your IXL assessment. You're going to DD1.